we know that when A is released from rest, in 2 seconds, B moves up 0.75 meters. So, what's the mass of it? So let's start this together, and then I can give you some time to think more about it.
Can we treat A and the bottom pulley as one unit?
Yeah. Because they are linked, so you can. So free body diagram is what we need to do. So 2 free body diagrams, one for A and one for B. So free body diagram, let's start with B. What are the forces acting on B?
Its weight.
The weight of B.
Tension.
The tension.
From B to B.
So of course it's along the rope. What else?
Normal force.
The normal force. And they tell us that it is smooth, so there is no friction. So that's it for B. Now let's do A. What are the forces acting on A?
MAG or minus MAG or the
Well,
weight of A.
I'm just going to say WAE. What else do we have?
Tension.
3 ropes keeping it up.
That's exactly it. So if you can neglect the masses of the pulley, the mass of the rope, then you can say that the tension is the same all along the rope. Same value of the tension. So if you look at A, and if you take A to be actually the pulley plus the rod that connects it to the block and so on, you see that there are 3 ropes that are supporting A. So it means that the force acting on A is going to be 3 times the tension. So that's important to notice that. So here we can say that we have 3 times the tension on A by the rope. And we can say that the tension on A by the rope is equal to the tension on B by the rope. Why don't I use vectors? Why not that?
Because the magnitudes are equal.
The magnitudes are the same, but of course not the direction. One is like this, the other is going to be straight up. And the fact that the tensions are the same comes from saying that the rope has no mass, or the mass can be neglected, and the pulleys also have no mass. So what do we do next? You have a problem like that.
I don't get why we have TAR equal TBR, because what I'm thinking is TBR is equal to 3 times of TAR.
Okay, so depends on how you look at it. If I call TAR the force, the tension in one rope, so I would have 3 of them. And they are all equal because we say the tension is the same everywhere along the rope. So the force would be 3 times that. And then, since this is the tension in the rope, it's going to be equal to the tension acting on B here. Now you could also say, oh, there is just one force here, and it's equal to 3 times what is here. It's exactly the same thing.
Okay.
But I prefer to think of it as the tension just in one piece of the rope, and then I count how many times it is connected to it.
Okay.
But what you said is also correct.
Okay, I got it. Thanks.
So what do we do next here?
Well, you have a distance traveled, you also have a time.
Okay.
So I was thinking you could find the distance by the time, but I don't think that'll work. Because that won't give you the acceleration, that'll give you the position.
If you have the distance and the time, what can you get from that? What kind of motion do we have for B?
And acceleration.
Right? And what do you expect the acceleration to be?
Oh, MGA. Or
Yeah. That's good. Is it going to be equal to G?
no.
No, it's not a free fall by far, of course. But do you expect it to vary, the acceleration? No, it's going to be constant. So if I were to take some axis here, I can call SA, and I can put the 0 where A is initially. What would be the form of SA as a function of time? If it is constant acceleration.
It would be a constant times.
When you have motion with constant acceleration, what's the formula?
S naught plus B naught T.
Right?
plus 1/2.
But you know that initially I can choose it to be at 0. Initially it has no velocity because it is released from rest. So then we just have the acceleration term. So it's going to be 1/2 acceleration of A T squared. So we know this at 2 seconds. So we can find AA. If we have AA, what can we do?
You can solve for SA. Or we can
Well,
find
no, we
the
knew.
weight of A.
Can you find
Or the mass of A.
the mass of A right away?
We'll have that
Right, so if
equation.
you do F net is equal to MA, well, you need to find the weight, basically.
Right, but it's just times gravity, right?
Say that again?
It's just times gravity.
Right, yeah. So if we find the weight, we have the mass. So if you have the acceleration of A, can you find the weight?
Yes, because you can find force net and divide it by the acceleration.
Well, what you're going to write is W minus 3 times the tension is equal to MA.
Oh, but you could
You
find
need
it
to
in
know the
terms of.
tension.
Right? You don't know the
Should we
tension.
start with B? You can solve the tension from B.
From B, so, right? So if we solve the tension from B, well, we need the acceleration for B. Do we know the acceleration for B?
It's going to be the same as.
Is it going to be the same as A? It's a pulley system.
It should be
It'll be
1/3.
constant.
It's going to be constant.